Hi, welcome. I know why you're here, and it's not to learn calculus, it's to join me in the simultaneous sip. So if you have your coffee ready, please join me. The question we're working on today is, show that the function f of x equals x to the third minus 15x plus 1 has exactly one root on the interval -2 to 2. So we'll start this question by writing down the function. It's f of x equals x to the third minus 15x plus 1 on the interval -2 to 2. And the way we're going to show that this function has exactly one root is that we'll show it has at least one root using the intermediate value theorem. So we'll use IVT to show that f has at least one root. And then we'll use the mean value theorem to show that it has at most one root. In order to use these theorems, we should first note that our function is continuous and differentiable on its domain, right? It's a polynomial, so it's continuous and differentiable everywhere. But in particular, it's continuous and differentiable on its domain. Okay, so in order to use the intermediate value theorem to show that there's at least one root, we want to find a value of x that makes our function negative and find a value of x that makes our function positive. So the IVT would say somewhere in between those values, our function has a root. So let's just try the endpoints. F of -2 is equal to -2 to the third minus 15 times -2 plus 1, which is greater than 0. And trying the other endpoint, f of 2 is equal to 2 to the third minus 15 times 2 plus 1, which is less than 0. So IVT says there is a root. What is happening here? There is a root, which we'll call capital A, in the interval -2 to 2, such that f of A equals 0. So we could conclude that f of x has at least one root. Okay, so now we'll suppose that there is a second root which we'll call b in the interval -2 to 2. Okay, so this means f of b equals 0. So now we're going to use the mean value theorem on the interval a to b. This means that there exists a number which we'll call, let's say, c in the interval a to b, such that the derivative of f evaluated at c is equal to f of b minus f of a all over b minus a. So we should take the derivative of our function. And our function is just a polynomial, so the derivative is 3x squared minus 15. Evaluating at c, we get 3c squared minus 15. And now we can use some values from above. We know f of b is equal to 0. F of a is also equal to 0. So the equation becomes 3c squared minus 15 equals 0. Which is the same thing as c squared equals 5, or c is equal to plus or minus the square root of 5. But note that the positive or negative square root of 5 is not in the interval -2 to 2. Therefore, there is no second root because that contradicts the mean value theorem. And so we could conclude that our function has exactly one root. And so draw a box and scribble your name in it to celebrate the proof of a nice result. Well, thanks for stopping by. I'll see you next time. Don't text and drive. Bye-bye.